Quantum information is a branch of science that deals with the study of how information can be stored, processed, and transmitted using the principles of quantum mechanics. Quantum mechanics is a branch of physics that studies how very small things, such as atoms and subatomic particles, behave. Imagine that you have a box with a lock on it. Inside the box, there is a secret message written on a piece of paper. In order to read the message, you need to open the lock and look at the paper. In this situation, the box is like a computer, the lock is like a computer security system, and the paper with the secret message is like the data that is stored inside a computer. Now imagine that instead of a box with a lock, you have a box that can be in two different states at the same time. In one state, the box is locked and you can't open it. In the other state, the box is open and you can read the secret message. This is what happens in quantum computers. Quantum computers use the principles of quantum mechanics to store and process information in a way that is different from how classical computers work. Classical computers, like the one you are using to read this text, use bits to store and process information. A bit is the smallest unit of information in a classical computer, and it can have one of two values, 0 or 1. In contrast, quantum computers use quantum bits, or qubits, to store and process information. A qubit is like a bit, but it can be both 0 and 1 at the same time. This is because in quantum mechanics, particles can exist in multiple states simultaneously. This property is called superposition. Using qubits, quantum computers can perform calculations much faster than classical computers. This is because they can manipulate multiple pieces of information at the same time, whereas classical computers can only manipulate one piece of information at a time. However, there are also some challenges to using quantum computers. For example, qubits are very delicate and easily affected by their environment. This makes it difficult to build and operate a quantum computer. The principles of quantum mechanics are difficult to understand and predict, so scientists and engineers are still working on developing the technology to make quantum computers more practical. Despite these challenges, quantum information is a promising field of study with many potential applications. For example, quantum computers could be used to solve complex mathematical problems that are too difficult for classical computers. They could also be used to improve communication and information security, by creating codes that are impossible to break. Overall, quantum information is a fascinating and complex field of study that combines the principles of quantum mechanics with the concepts of information and computation. It has the potential to revolutionize the way we store, process, and transmit information, and to unlock new possibilities for science and technology.